Stars are giant balls of hot gas. They shine brightly in the night sky. We use the Hertzsprung-Russell, or HR diagram, to understand stars. This diagram charts a star's brightness against its temperature. The HR diagram helps us track a star's life from birth to death. A star's life is a journey with distinct stages. It begins as a nebula, then becomes a main sequence star. As it ages, it transforms into a red giant. Finally, it ends its life as a white dwarf, neutron star, or black hole. Stars are born in nebulas. Nebulas are vast clouds of gas and dust. Gravity pulls these particles together. The cloud gets denser and hotter. Eventually, nuclear fusion begins. Hydrogen atoms fuse to form helium, releasing enormous energy. This is how a star is born. It enters the main sequence, the longest stage of its life. Our sun is a main sequence star. It's been shining for billions of years. It will continue to do so for billions more. During the main sequence, a star is in a delicate balance. Gravity pulls inward, trying to collapse the star. The outward pressure from nuclear fusion counteracts this force. This balance keeps the star stable and shining. The larger a star is, the hotter it burns and the shorter its lifespan. Eventually, a star runs out of hydrogen fuel in its core. Fusion slows down and the outward pressure decreases. Gravity takes over and the core contracts. As the core shrinks, it heats up. This heat causes the outer layers of the star to expand dramatically, turning the star into a red giant. Red giants are much cooler than main sequence stars. They appear reddish because they emit more red light. Red giants are huge. If our sun were a red giant, it would engulf Earth. This phase doesn't last forever. Eventually, the red giant runs out of fuel completely. What happens next depends on the star's mass. Smaller stars like our sun end their lives relatively peacefully. They shed their outer layers into space, forming a beautiful planetary nebula. The remaining core, a white dwarf, is incredibly dense. It's about the size of Earth, but contains as much mass as the sun. White dwarfs slowly cool down over billions of years. Massive stars, on the other hand, have a more dramatic end. They explode violently as supernovas, the brightest events in the universe. Depending on the core's mass, a supernova leaves behind either a neutron star or a black hole. Neutron stars are incredibly dense, even denser than white dwarfs. Black holes are even stranger. They have such strong gravity that nothing, not even light, can escape them. The life cycle of a star is a fascinating journey. By studying stars, we gain a deeper understanding of the universe and our place within it. So next time you look up at the night sky, remember the amazing life cycle of the stars twinkling above. Don't forget to stay curious and explore everything.